Hello. These are 1.1 notes, and these are the simple version. This is really all the notes you need to take for this section. The small number equals protons, which also equal electrons. And what do I mean by small number? What I mean by small number is if you look at the periodic table and you look at something like lithium, which one's the smaller number? 3 is the smaller number. So when I say small number or big number, that's what I mean. And also I rounded this. If you look at the periodic table, this number will be like 6.941 or something like that. You round it. You look at sodium on the periodic table, and this number is like 22.98 or something. So you always round that goofy number when we're doing this today. Okay? So that's what I mean by big number and small number. Small number is the protons and the electrons. How do you find neutrons? The neutrons is the big number after you rounded it minus the small number. And this electron rings, right? Electrons are on the outside, and the first ring can hold up to 2, can hold 1. This is probably the most common mistake we make in the beginning is the electron rings, and I'll show you in a second how to do it. But the first ring, which we like to call energy levels, can hold 2, it can hold 1, or it can hold 2. The second ring can hold up to 8. It can hold 1, 2, 3, 4, 5, 6, 7, 8. It cannot hold 9. And once you fill this inner ring, you cannot move to the outer ring until you fill the inner ring. Okay, if this is goofy, I promise you, I'll show you in a second, and it will make sense. But the inside ring can only hold 2. The next ring can hold up to 8, and the next ring can hold up to 8. In real life, it gets more complicated than that, beyond that. But from now, for us, it's a great place to start. It's a great foundation for us to just think it's 8, 8, 8, 8, 8, 8. And there's technically, an infinite amount of energy levels that electron can be in. Okay? All right, so let me show you an example. All right, so let's see here. All right, so for hydrogen, we'll skip hydrogen. Hydrogen's pretty easy. Okay, so let's look at lithium. Lithium, the small number is 3. So if the small number is 3, that is the protons are 3 and the electrons are 3. Now, why is that true? Nature always tries to balance itself out. Protons are positive, electrons are negative, and nature tries to balance itself out. So that's why the small number is the protons and the electrons. Okay, now how do you find the neutrons? The neutrons is the big number minus the small number. So if you look at lithium, big minus small, 7 minus 3 is 4. Now, a lot of times people will get lithium wrong. That's why I put lithium as an example. Because on the periodic table, this number is 6.9. And people go, I think 6 minus 3 is 3. I think that's what they do, and that is incorrect. Remember, you have to round this. 6.9 is way closer to the 7. Okay? They might round it wrong too. All right, you're only looking at that first digit. 6.9 is closer to 7 than it is to 6. All right, so we're going to round that to 7. Now, there are lots of ways to draw atoms. To make it simple and quick, I just symbolize it, right? So these two things are in the nucleus, which is the center of the atom. So I just abbreviate and say there are 3 positive protons. There are 4 neutrons. Another common mistake students will make is they'll see the P and hear positive and go P positive, P positive. And then when I ask them what a neutron is, they'll say negative. That is incorrect. Neutral means in the middle, right? So a proton is positive. An electron is negative. Neutrons are neutral or in the middle, which means they have no charge. So this little circle I put as 0, meaning it has 0 charge. Okay? That is the nucleus. That is the center of the atom. Electrons go on the outside. There are 3 electrons, but you cannot put 3 electrons in the first energy level. That is incorrect because remember, the electrons, the first energy level can only hold 2. So you have to fill the first energy level with 2. You cannot put 3 in there, but it does have 3. So that answer is not correct either because it has 3 electrons. You have to show 3 electrons. So once you fill one energy level, you then have to go to the next energy level. And that is a decent model of what is how a lithium atom behaves. Okay. The last thing is outer electrons. A lot of times students will say, well, the electrons, all of them are on the outside. What we mean is, if you were to take your finger, the first thing you hit is the outside. It's like an apple. That's the outside of the apple. This is the outside. This is the inside. They're inside, right? This is outside. So the outer electrons is 1. And that is how you would do lithium. I'll show you one more. I'll show you sodium. Okay. Let's erase this. All right, so sodium, we got small number 11. That means you got 11 positives, 11 negatives. For us, for now, those will always be equal. Neutrons is the big number minus the small. Again, on the periodic table, this is like 22.9. That rounds up to 23. 23 minus 11 is 12. Therefore, you have 12 neutrons. These two things are in the middle. It's called the nucleus. So we say there's 11 positive protons, 12 neutral, zero charge neutrons, and now we have an 11 electrons, right? And you got to get that pattern in your head, the 2-8-8-8-8 pattern, right? So hopefully you wrote that down. You take a look at it, and you can look at it while you're practicing, right? That's how you learn. Look at it, practice. Look at it, practice. Make a mistake, fix it. Look at it, practice, right? So I know I need to make 11. Well, the first ring can only hold 2. The next ring can hold 8. 2 plus 8 is 10. We're still not there yet. So the next ring is filled up. 2 plus 8 is 10. We have 11, which means there's one more in this level. And again, outer electrons are just what's on the outside. So if you don't understand that, you take your finger. First thing you touch, boom, 1. Outer electrons, 1. And that is a decent model of how a sodium atom behaves. 11 protons, 12 neutrons in the nucleus, 2 electrons in the first energy level, 8 electrons in that level, and 1 in the third outer level. If you have any questions, please email me.